Okay, welcome back to what I hope to be final part 3 of Notes in 1-2. Okay, we're looking at simplifying algebraic expressions, and we've been dealing with rational expressions, or algebraic fractions, some people like to call them. All right, so I'm looking here, x minus 3, 3 minus x. Now, they're pretty close, but, since subtraction is not commutative, we know they're not identical. Okay, so we need to take a look. Can I rewrite this in some way that's going to be helpful? Well, I always like to put the x term first, but if I move the x term to the front, then that's going to be a negative leading coefficient. I don't really like to do that, so I'm going to go ahead and say -1. Okay, and that's going to change my signs and give me x minus 3. Okay, and now that I've done that, now I have x minus 3 in both. I just have this extra -1. So I just need to give the -1 to this denominator, which means I've got to give the -1 to the numerator as well. Okay, so that changes this to -x squared plus 9 over -1 times x minus 3. Okay, now again, I've got this leading coefficient of -1, so I can rewrite this as -1 times x squared minus 9 over -1 times x minus 3. And probably you see it already. I have the same number in the numerator as the denominator, so I know that that's actually equal to 1. So it effectively cancels out. All right, so now I've got x squared minus 9, two terms. They're perfect squares, so I'll rewrite that as x plus 3, x minus 3, and that's over x minus 3. And now I have common factors in numerator and denominator. So they effectively cancel out, and my final answer is x plus 3. Okay, pretty sweet. Okay, now these last two are the stuff nightmares are made of sometimes, but they're really not that bad because they're just really complex fractions. Okay, so what we want to do is we want to attack them in little bits. Okay, what I prefer to do with this type of problem is to break it down, okay, into parts. First thing I'm noticing is this numerator could be simplified because it's already two separate fractions. Okay, so I would want to rewrite my numerator. Instead of having 1/2 plus 1 over x, I want to go ahead and get those to be common. So this x needs to be in the numerator here, and this 2 needs to be in the numerator. I meant denominator. Sorry about that. Okay, so that's going to give us, if we place that there, then we also need 1 in the numerator. And then on this side, we're going to add the 2, or multiply by the 2. So we have it, same thing on top and bottom. Okay, so now this simplifies to x plus 2 over 2x. Okay, so that is the simplified form of my numerator. I'm going to look at my denominator. Okay, I have x plus 3 over 4. Well, there's not really anything to do there. It's x plus 3 is prime, 4. We could write 2 times 2. I'm not sure if that'll help us any at all, but we can go ahead and write that down that way. Okay, so now the denominator is simplified. Now, this can either be looked at as a fraction or division. For this particular problem, I'm going to look at it as division because I know if I'm doing fraction division, then I just multiply by the reciprocal. Okay, so if this is my original, then the reciprocal will be 2 times 2 over x plus 3. Okay, so in this factored form, I notice that we have a 2 and a 2. So now I have x plus 2 times 2. I'm going to go ahead and put that in the front because it just looks wrong to me to do it any other way. Okay, and then put the x plus 3 in the denominator. That's it. That's all she wrote, simplified. Okay, so when you take it in little parts, not so bad. All right. So let's attack the next problem. Again, looking at the numerator. Okay, I have x squared minus 4 and x minus 2. So I know I need common denominator. So I'm going to go ahead and factor x squared minus 4. I'm just going to kind of do that out to the side. Okay, so they're perfect squares, so x plus 2, x minus 2. So if that's x plus 2, x minus 2, this denominator has the x minus 2, so I don't need to add anything at all to this one. I just need to put x plus 2 in the numerator and denominator there. Okay, so that's going to give me x plus 3x plus 6 over x minus plus 2, x minus 2. Okay, so I can go another step. That's going to be 4x plus 6 over x plus 2, x minus 2. They both have a common factor of 2, so I can go another step. And that's pretty much all I can do with that numerator. So now I'm going to look at my denominator. X plus 2, x minus 2. Each side needs the other's factor. So we're going to have 5 times x minus 2 over x plus 2, x minus 2. And then we're going to add 4 times x plus 2 over x plus 2, x minus 2. Okay. Again, x minus 2 needed it for the denominator, so I had to give it to the numerator. Alright, so if we multiply this out, we have 5x minus 10 plus 4x plus 8 over the denominator. 5x plus 4x is 9x. Negative 10 plus 8 is negative 2. Alright, now since it's the denominator we were dividing, we need to multiply by the reciprocal. So we're going to put these guys back together. And we're going to have 2 times 2x plus 3 times okay, and I'm seeing the same x plus 2, x minus 2 in numerator and denominator, and that's the only things I'm seeing cancel out. So putting it back together, I'm going to have 2 times 2x plus 3 over 9x minus 2. Okay. Alright, yay, we finally finished notes 1-2.